so well to like, comment, and subscribe on this channel. So today we are going to be looking at question on fluid mechanics, which is on metacentric heights. So today we are treating metacentric heights. Now I've explained, on my previous video, if you check my previous video, I explained what is metacentric height. So you can do so well to click on, I'll drop the link on my previous video where I explained metacentric height. So today we are going to be looking at another question on metacentric height. They said a cylinder of 200 mm in diameter and 800 mm in length has its base to be 20 mm thick and specific gravity of 6. The remaining part of the cylinder is of specific gravity 0.6. State if it can float. Now, I briefly explained on the previous video how a substance or the condition in which a substance can be able to float. I said basically it's to determine the metacentric height. When you have the value of the metacentric height, if it's positive or negative, to tell you whether the substance or the medium should be or should not be able to float. So basically what we are going to be looking for here is to state if it can float, is calculate the metacentric height. So that's what we're going to be looking for, to calculate metacentric height. So before we start solving, let's write out or take note of our parameters. So basically we have 20 mm, there is a cylinder of 20 mm in diameter. So we have diameter D of 200 mm. So basically I want to work with meters, the unit of meter. So I have to convert this millimeter to meter. So converting 200 mm to meter, what do I have? I have 0.2 meters. Then we have 800 mm length. So the length of the cylinder or the height of the cylinder is basically 800 mm. So call it capital letter H, 800 mm. So converting 800 mm to meters, I have 0.8 meters. Then it has its base to be 20 mm thick. So the total length of the cylinder is 0.8 meters. Then it has its base. The base of the cylinder is, let's say for instance, made up of an entirely another substance. So with respect to the top part of the cylinder, the base is made up of entirely another substance and it's 20 mm thick. Meaning that the height of the cylinder, let's call it small letter h, 20 mm. So let's call it h2, 20 mm. Converting 20 mm to meter, we have 0.02 meter. And the specific gravity is 0.6. So the base of the cylinder is having specific gravity 0.6. That's the that is made up of an entirely different substance. So let's call it S2. Sorry, it's made up of 6. Let's call it S2, which is 6. And the remaining part of the cylinder, which is the top part, is made up of 0.6. So let's call it S1, 0.6. Now we have to state if it can float. Now basically what we are looking for is the metacentric height. So what's the formula for metacentric height? Metacentric height, which states Gm is equal to I, which is the moment of inertia, divided by V. V is the volume of water displaced, or the volume of fluid, or sorry, the volume of the medium in the fluid. Then minus Vg. Vg is basically the distance between the center of buoyancy and center of gravity. Basically the distance between the center of buoyancy and the center of gravity. So basically when we have all these values, we can easily find the metacentric height and we can easily state if it can float. So before we start solving for metacentric height, let's get the value of my Vg. The Vg is the distance between the center of buoyancy and the center of gravity. So how do you get the distance between center of buoyancy and center of gravity? Vg has a formula which basically states that Vg is equal to Og minus Ob. Now Og meaning distance from the base of the cylinder to the center of gravity minus Ob, which is distance between the base of the cylinder to the center of buoyancy. So let's calculate Og. Now, to calculate OG, basically we are going to take similarities. We are going to take similarities between the center of buoyancy, we are going to take similarities between the depth of immersion and the height of the cylinder. Now, basically, since the cylinder is made up of two substances, so we assume that the OG, the center, is going to have a central center of gravity. The top cylinder is going to be down the base of the cylinder. So, assume this one has its own center of gravity, and the top cylinder has its own center of gravity. Then we have a general center of gravity, which I represented as capital letter G. So we have G1 here, we have G2 here. So OG, which is the base of the cylinder to the central center of gravity, multiplied by the depth of immersion of the whole cylinder. Let's call it by H1. Depth of the depth of the cylinder of the top part. Then let's call by H2. which is the depth of immersion of the bottom part. So let's assume OG, which is central center of gravity, multiplied by the total depth of immersion, which is by H1 plus by H2, will be equal to the center of gravity of the top part multiplied by the depth of immersion of the top part. So what is the center of gravity of the top part? Which we do, that is dividing the center of gravity of this one, adding it to this one. That is the distance from this place to the center of gravity of the top part of the cylinder, which will give me the H2, taking the distance from here to here, and also taking half of the distance from here to here, which will include, that is OG, which is H2 plus H1 divided by 2. H2 plus H1 divided by 2, that is OG1. The center of gravity, taking the distance from O to the center of gravity of the top part of the cylinder, will include this distance plus this distance divided by 2. So, multiplied by the depth of immersion of the top cylinder, which is H1, plus the height of gravity of the base of the cylinder, which is OG2. So, from the base of the cylinder to OG2 is H2 divided by 2. H2 divided by 2, multiplied by the depth of immersion of the base of the cylinder, which is by H2. So this is basically how we are going to look for the OG. So dividing both sides by H2, what do we have? Dividing both sides by the total depth of immersion, which is by H1 plus by H2. Then what do we have? We have OG is basically equal to H2 plus H1 divided by 2 times by H1 plus H2 divided by 2 times by H2 divided by H1 plus by H2. We have the value of H2 and we don't have the value of H1. Now basically what's H1? If from this part to this part is H2 and H2 we said is 20 mm, which is 0.02 meters. So and if the total height of the cylinder is 0.8 minus 0.02, so that means H1 gives me 0.78. So the H1 is 0.78 meters. So we have our H1 which is 0.78, but we don't have the depth of immersion of the top cylinder and the depth of immersion of the bottom cylinder. So how do we get the depth of immersion of both the top and the bottom cylinder? So we said there's a rule that says the specific gravity multiplied by the height of any medium will give me the depth of immersion of that medium. So basically the specific gravity multiplied by the height of any medium will give me the depth of immersion of that medium. So basically that's what we're going to apply for in solving my OG. So basically for depth of immersion 1, we have specific gravity of 1 times the height of the top cylinder, which is H1. So specific gravity S1 times H1, and H1 is 0.78. So we have S1, which is what? 0.6 times 0.78 gives me 0.468 meters. So I'm going to be looking for the depth of immersion of the bottom cylinder, which is by H2, which is S2 times H2. Specific gravity, which is S2 of the bottom cylinder, which is 6, times the height of the bottom cylinder, which is 0.02. We have 6 times 0.02, which gives me 0.12 meters. So to get the total depth of immersion, let's call it by H. That is the total depth of immersion of the whole cylinder. That is by H total. We have 0.468 plus 0.12 is equal to 0.588 meters. This is the total depth of immersion of the whole cylinder. But that's what we are looking for. We are looking for OG. So since we have the depth of immersion, we can easily get OG, or we can easily substitute it here in the equation. So basically OG is what? H2 plus H1 divided by 2. We have H2 is what? 0.02 plus H1, which is 0.78 divided by 2, multiplied by H1, and we know by H1 is S1 times H1, right? Which is equal to 0.468 plus H2, which is what? 0.02 divided by 2 times by H2, which is S2 times H2, which is equal to 0.12 divided by H1 plus by H2, which is 0.588. So solving this gives me 0.32 meters. Now we've successfully gotten the value of my OG, which is 0.328 meters. So now remember we are looking for BG. So we are getting OG. What's left is to find OB. And OB is the distance from the base of the cylinder to the center of buoyancy. So to get the distance basically from the base of the cylinder to the center of buoyancy, we are basically just dividing the distance divided by 2. What am I trying to say is that we are basically dividing the depth of immersion of the body in the fluid divided by 2. So if you have a medium in a particular, if you have a body in water, and if you have the center of buoyancy is known, or basically the depth of immersion of that body is known. What I mean by depth of immersion of the body, when the body is immersed in a fluid, depth of immersion is basically the distance that body is underwater. So this is basically called the depth of immersion, while it is called the height of the body. So this is depth of immersion. So basically to get the OB, which is the distance from the base of the cylinder to the center of buoyancy, we are basically dividing the depth of immersion by 2. So to get my OB is basically the total depth of immersion of the body, which you calculated as 0.588 divided by 2. So OB 0.588 divided by 2, we have 0.294 meters. So that's the depth of immersion of the total depth of immersion divided by 2 give me my OB. So now I have successfully calculate my BG. So my BG is equal to OG, which I calculated as 0.328 minus OB, which is 0.294, gives me 0.034 meter, which is 0.0384 meter. So now let's calculate the value of my moment of inertia. So basically I have the value of BG, this one is off, then we calculate the value of moment of inertia. So what's the moment of inertia of a cylinder? It is basically by d raised to power 4 divided by 64. So the diameter of the cylinder, which we are given to as 0.2 meter. So pi times 0.2 raised to power 4 divided by 64. So when we solve this, the value of what we get is going to be 7.85 times 10 raised to power minus 5 meter raised to power 4. So that's the value of the moment of inertia. So to get the volume of water in space, which is V. Now the volume of water in space is the same thing as the volume of the fluid immersed when it is underwater or when it is in any medium or any fluid or any liquid. So basically the weight of the volume of the cylinder in that liquid, that is the volume of water displaced by that body. So to get the volume of the cylinder in that liquid is going to be area of the cylinder times the depth of immersion of that cylinder in that liquid, which is equal to depth of immersion that we calculated. So the area of the cylinder which is given as what? By d raised to power 2 divided by 4 times the depth of immersion. So by d raised to power 2 divided by 4. So basically we are going to be having the diameter which we are given to as 0.2. We have pi times 0.2 raised to power 2 divided by 4 times the total depth of immersion which we are given to as 0.588. 0.588. So the volume of water in space given is basically 0.0135 meter raised to power 3. That is 0.0135 meter cube. So we have successfully calculated all the parameters we need to get the metacentric height. So let's calculate the metacentric height. So now to calculate the metacentric height, we need this and this, and we've gotten all of them. So now let's just include our values in there to calculate our metacentric height. So our metacentric height is Gm is equal to I, which is the moment of inertia, which we got to as 0.7.85 times 10 raised to power minus 5 divided by volume of water displaced, which is 0.0135, 0.0 minus the distance between the center of buoyancy and center of gravity, which is 0.034 meters, 0.034 meters. So solving this or simplifying this, we are going to be having the center of the metacentric height Gm to be equal to minus or the negative of 0.0301 meters. So what is this telling us, this is basically telling us that now, because the question says think if it can float, so you can easily conclude that the body should not be able to float or cannot be able to float because the value of the metacentric height is a negative value and the center of gravity is below the metacenter. Anytime the center of gravity is below the metacenter, it should not be able to float. So this is the conclusion we have, because the metacentric height of the body is a negative, gave us a negative value.